So we're going to say a positive and a negative coterminal angle for 7 pi over 6. Does it say you have to draw the angle? No. So, and again, on the test, I've made a lot of these multiple choice, so, you know, there wouldn't be any work. I'm just checking if you put A, B, C, or D. But here's my suggestion. Draw it anyway. The visual helps a lot, and then you can see it. So what quadrant is 7 pi over 6 in? 3. Good. It would look like this. It just takes 2 seconds, then you have a visual, all right? So if you want a positive coterminal angle, you're going to go your 7 pi over 6 plus once more around. What is the whole way around the circle in radians? 2 pi. Good. So it is going to be 2 pi plus 7 pi over 6. And so what it really comes down to is adding fractions. You need a common denominator, which would be 6. So here's the question. How many 6 is a whole 2? 12. Good. Okay, so it is 12 6 plus 7 6. And once you get there, it's just adding. 12 plus 7 gives you 19, so 19 pi over 6. To get the negative one, that's like you go this way, I'll go the other way. We're going to meet on the other side. For that one, you're going to subtract. So you would have your 12 6 minus 7 6, which would be 5 6. But what do you put just to indicate you went backwards? Negative. Good. So it will be negative 5 pi over 6. Number 2 is the exact same thing, except it's in degrees. Again, you don't have to draw it, but I just highly recommend that you do because I think it helps a whole lot. Negative 95 is actually kind of tricky because it's like just past 90, and we also went negatively. So what quadrant is that going to be in? Be really careful. 3, good. You went backwards negative 90, and then like another 5, so negative 95. All right, so a positive coterminal angle would be this one. So you're going to take the whole circle, subtract 95, and that'll give you what's left for this positive amount. So what's the whole way around in degrees? Good. So we're going to do 360 minus 95. You have to do some borrowing there. So 265 degrees. Forwards will get you to the same place. Now, because this angle was already negative, getting a negative coterminal angle is a little tricky. And again, that's why the visual helps. Just watch me point to this. It means you went negative 95 and then negative a whole nother rotation. So you went backwards 95 and then backwards another 360. So we're going to add them together and then just put a negative in front of it to show that we went backwards. You're going negative 95 and then another negative 360. So that is going to be 455, but again, just make it negative to show you went back. So my suggestion is draw the picture. You don't have to, but that's my 2 cents. Okay. 3 and 4 are name that quadrant. We're going to go over these ones. If you're like, hey, I need some more practice with that. This was in homework 2. I think it was the very first section. You can go back to that in Delta Math and it'll keep feeding you problems if you just practice some more. Here's a little acronym to see where they're positive. It was all students take calculus. They're all positive in quadrant 1. What did the S stand for? Sine. So sine is positive in quadrant 2. And so also cosecant, the ones that go together, the reciprocals. What did the T stand for? Tangent. Good. So tangent and also cotangent are positive in quadrant 3. And then the C was for cosine. Cosine and then secant are positive in quadrant 4. So you really just need to look for the positive one and see where it lands. Sine is negative, so don't worry about that. Secant is positive. That's really the one you need to look at. Where is secant positive? 4, the same place as cosine, so quadrant 4. And then for this one, sine is positive, cotangent is negative. You really just need to look at the positive one. Where is sine positive? Well, I guess they're all positive in quadrant 1, but it can't be quadrant 1 because we have something else that's negative. So where else is sine positive? Let me phrase it that way. 2, good. So again, that was in homework 2, the very first section. If you just wanted to practice a whole bunch more of those, It'll just keep feeding you problems, all right? 5 and 6, I'm going to say the same thing as I did for 1 and 2. I would draw it. Again, you don't have to, but it's my suggestion. What quadrant is 135 going to be in? 2, good. So that's what the angle looks like. And then this part is your reference angle. It's either going to be 30, 45, or 60. Those are the only 3 choices. So what is this one? 45. If it ends with a 5, it has to be the 45. And then this one, where is 2 pi over 3? 2, good. And so your reference angle is this part, and that would just be pi over 3. For the radians, the denominator just matches. So that one's really, actually, you kind of don't even need a picture for that one. It's either pi over 6, pi over 4, or pi over 3, and the denominator just matches. All right, so for these, we have to figure out what quadrant we're in and draw the triangle. This says cosine is negative and tangent is positive. So again, you really just need to look at the positive one. Where is tangent positive? 3, good. Draw yourself a triangle in quadrant 3. And labeling the triangle is like your quote unquote work. These problems don't really have like steps to them. It's like labeling the triangle is your work. So cosine is adjacent over hypotenuse. So 5 is the adjacent, 13 is the hypotenuse. Then decide which one gets the negative. So is it the 5 or the 13 that gets the negative? Good, because we went left. Also, the hypotenuse can never be negative, just kind of like by definition. And then we're told tangent is 12 over 5. That's opposite over adjacent, but it's not 12, it's negative 12. Good, because you're in the third quadrant. And that's how tangent ends up being positive, is the negatives cancel. All right, anyway, that's your work. Now we answer the question. We want sine. Sine is, well, actually, I should ask you guys, sine is what over what? Good, opposite over hypotenuse. So that is going to be, for this problem, that would be what? Good, negative 12 over 13 is your answer. Number 8 is tricky because it just says cosecant is negative 5. You want to think of that as negative 5 over 1. It has to be a ratio, something over something else. And I'm not sure which gets the negative, if it's the 5 or the 1. We have to wait until we draw it. Now we're flat out told it's quadrant 3, which is always nice whenever you're told exactly what quadrant it is. Cosecant is hypotenuse over opposite. It's the reciprocal of sine. So 5 is the hypotenuse, 1 is the opposite. Which one gets the negative? 1, good. Now for this one, you're going to have to do Pythagorean theorem to get the other side. Can we just call it A? Is that okay with everybody? You have to call it something. All right. A squared plus negative 1 squared equals 5 squared. So that'll be a squared plus 1 equals 25. So a squared equals 24. And now this one splits. If it doesn't split, you don't have to worry about it, but this one does. How will 24 split? 4 and 6, good. And then that will reduce to 2 square root of 6. However, it's not 2 square root of 6. It's actually negative 2 square root of 6 because you're in the third quadrant. All right, phew, that was the work. We have our triangle labeled. Now we answer the question. It's asking for cotangent. That is x over y, or adjacent over opposite, however your mind wants to do that. Negative 2 square root of 6 over negative 1. Negatives are going to cancel, and so it's just 2 square root of 6. Easy and difficult is always an opinion thing, but I think that's the hardest problem on here. You had to do a lot for that, and there was a lot of room for error with all the negatives and everything. All right, here are your conversions. You did well on this on the quiz, just do it again. To turn the degrees into radians, what are we going to multiply by? Good, pi over 180. The degrees cancel and so do the zeros, which is fantastic. It's 34 pi over 18. They'll both divide by 2. So how does that fraction move? 17 over 9. Good. Perfect. 17 pi over 9. And then for this one, you're going to do the exact opposite. You're going to multiply by 180 over pi, or I should say reciprocal, not opposite. And then the pi's cancel. And then you can kind of think through this however your brain does it best. Here's what I would do. I would keep the 5. And then we're going to do 180 divided by 12. And again, some people can do that in their head. I would just write it off to the side. 180 divided by 12. If you don't need to write it, then that's fine. How many times does 12 go into 18? Once. Good. If you subtract 12, you get 6. Bring down the 0. And then 12 goes into 60 5 times. So we got 15. And so then it's 5 times 15, which would be 75. So 75 degrees. And then these last two, 11 and 12, those are your little formulas. Again, do just like you did on your quiz. What was the formula for an arc length? I'm just going to write it off to the side. Good. You just multiply them together. For the area, it was 1/2 r squared theta. The only thing is theta has to be in radians. So if it's not, then you have to convert it, which bummer, this one isn't. So we're going to take our 40 degrees, multiply it by pi over 180. You have to convert it first. So when you cancel out, that's going to give you 4 pi over 18, 2 pi over 9. Good. And then that formula, you just multiply them together. It's going to be the radius, which is 6, times 2 pi over 9. So 6 times 2 is 12. And then how would we reduce 12 ninths? They'll both divide by 3. So 4/3. 4 pi over 3 is your answer. Just don't forget to put units. It is meters. And then this one, the angle is already in radians. So you can just go ahead and plug everything in. 1/2 times 4 squared times 3 pi over 4. Again, you can think through this however you want. Here's what I would do for this one. What is 4 squared going to give us? 16. Good. Half of that. 8. Good. So we'll have 8 times 3 pi over 4. 8 times 3, 24, divided by 4, 6. So 6 pi, and then because it's an area, it's going to be yards squared. Good. So again, most of this stuff on the front page is like your quiz 2.0. If you did well on your quiz, just do that again. If you didn't, look back at your quiz and fix, whatever it is you needed to fix. A lot of these are multiple choice on the test. All right, take like a 2-minute break and then we'll do the other side. 13, 14, and 15 are not on the unit circle. Those are the ones where you're gonna have to do Pythagorean theorem to get the hypotenuse. And remember, it comes out to something weird, like square root of whatever. Do you guys remember those? Okay, what I would do is off to the side, let's list out the 6 trig functions and write out what they equal. And this is what I would recommend that you write on your paper for your test when you get it, just so that you have it off to the side and you can refer back to it. So just go ahead and list out all 6 and then we'll write out what they are. And I guess if you even want to draw the triangle, you can. I like a visual, it helps me. X is left to right, Y is up and down, your x-axis and your y-axis, and then R is the hypotenuse. So this comes from SOHCAHTOA. It's still no different than in geometry class. Sine is opposite over hypotenuse, so that's going to be Y over R. cosine is going to be adjacent over hypotenuse, so that's x over r. And then what would tangent be? Good, y over x. And then what are you going to do for these three? Reciprocal, just flip them, right? So this will be r over y. Secant would be r over x. Cotangent is x over y. Now, like I said, these ones are not on the unit circle, so r is going to just be whatever it is, and it kind of is a mess because you have a square root in there, but oh well, just leave it. When you do the unit circle ones, that means r is what? 1. You can rewrite it if you want whenever we get to these problems down here for the unit circle, but it is the exact same thing except r is 1. Okay, so it's no different. The hardest part, honestly, is figuring out what quadrant you're in. All right, so let's look at 13. Cotangent is positive, and then cosine is negative. You really only need to look at the positive one. Where is cotangent positive? Which quadrant? 3. Good. Draw your triangle in quadrant 3. And cotangent is x over y. So 5 is the x, 2 is the y. However, they need to both be negative because you're in the third quadrant. So we're going to do Pythagorean theorem to get the hypotenuse. It's going to be -2 squared plus -5 squared equals r squared. You guys have done Pythagorean theorem so many times now, you're probably just like doing it in your sleep, I hope. All right, that's going to give you 4 plus 25 equals r squared. So that would be 29. Now, when you square root that, square root of 29 doesn't split. If it did, you would need to do that. Like the one we did on the other side of the paper was 24 and we split it 4 times 6. But if it doesn't, then just don't worry about it. That's it. And now we're going to write out all 6 trig functions. Everyone keeps asking me, do we have to write them on the test or will they be printed? On the test, they'll be printed there, okay? And actually on the test, there's only one problem where I have you do all 6. The other ones, I just kind of pick and choose a couple of them. But to be honest, that actually throws people off and they end up usually writing all 6 off to the side anyway, because it's like a process and just do all of them. So I don't know, there's only one where I make you do all of them though. So the triangle is like your work. And then we're just going to go and list these out. Sine would be opposite over hypotenuse. So that's going to be -2 over square root of 29. Cosecant, you're just going to flip that. And I realize some of these we're going to have to rationalize, but I usually just write them all out and then just go back and fix the ones that need fixing. There will only ever be 2 that you have to fix. All right, what is cosine going to be? What over what? You only got 3 sides, so there's not a whole lot of choice. Good, perfect. -5 over square root of 29. And so for secant, just flip that. And then tangent would be what over what? Good, opposite over adjacent, or y over x. That would be -2 over -5. The negatives cancel, so 2/5. And then cotangent is 5 over 2, which was actually given in the whole. Now, which 2 do we have to rationalize? There will always be 2 you have to go back and fix. Good, sine and cosine. This will be -2 square root of 29 over 29 and -5 square root of 29 over 29. There's only 3 sides to the triangle. You end up writing the same. Does it feel redundant? It should. Like if you feel like you're writing the same thing over and over again, good, because that's kind of 14 and 15, I'm just going to help you do the work of, filling in the triangle. I'll leave this to you. I suggest you do it and check, Schoology though. I have all the answers up there, but let's just get the triangle because I think that's the hard part. What quadrant is this point in? -6, 3, 2. I like when they give you a point because I think that's the easiest sort of version of this because it's easy to figure out what quadrant you're in. -6 is the x, 3 is the y. And again, we're going to do Pythagorean theorem to get the hypotenuse. So -6 squared plus 3 squared equals r squared. So let's see, 36 plus 9. So 45. Now, when you square root, that one is going to split. How would we split up 45? Perfect, 9 and 5. So it will be 3 square root of 5. And then you would list out the 6 trig functions and reduce the ones that need reducing. Again, I suggest you do that in preparation for your test and then check the answers. I have them posted. The only difference between 14 and 15 is you have to get the point yourself. Now you can plug in anything for x that your heart desires as long as it's what? Good, it has to be positive, bigger than 0. Now you can plug in anything you want, but there's an easy way and a hard way. You want this fraction to cancel. So 3 would be a good choice to plug in, because when you plug in 3, what will happen? They'll cancel, good. You'll just have -2 minus y equals 0, and then you can solve that fairly easily and you won't end up with a fraction. So pick something that will make the fraction cancel out, right? So for this, you would add over the 2, divide by a negative, and so you get -2. So again, the only difference between 14 and 15 is for 15, you had to get the point yourself. Now let's draw the triangle. What quadrant would that be in? 4, perfect. So x is 3, y is -2. We're going to do Pythagorean theorem again. So that would be 9 plus 4 equals r squared, which would be 13. When you square root that, it's not going to split. So just leave it square root of 13. And then again, you would list out the 6 trig functions. All right, this last section here, this is your like bread and butter of pre-calculus. This is what we were doing when we played Battleship. I'm not going to do all of them because I want you guys to practice them. And also, this was homework 4. If you just want to practice some more problems, go back to Delta Math homework 4. It'll keep feeding you more problems. I'm going to let you guys pick 5 for us to do together. I would suggest you pick something that's a 6th, something that's a 4th, and something that's a 3rd, so that we can do kind of like one of each of them. But I'm going to let you guys decide. What on here, like what one looks scary to you that you want to pick? All right, everyone look at 27. Oh, that's a good choice too, because that one's actually not going to create a triangle. That's one of the ones that lands on an axis. So it's going to make a circle. Draw your little bullseye. Yes, you have to draw this for every. I'm not asking for a whole lot. I'm asking for a circle or a triangle. My expectation is reasonable. I'm not asking for a paragraph or 10 steps of work. So just please draw it for me. Where is 3 pi over 2? Up, down, left, or right? Down. Perfect. What is that point? 0. -1. That's it. That's the work. That's all I'm asking for. It's not a lot. Please work with me. Then you answer the question. Tangent is y over x. That's going to be -1 over 0. You cannot divide by 0. So undefined. That's all the work I'm looking for. So just do it. Why don't you guys pick another one? 17. Now think about where 11 pi over 6 is on your unit circle. Again, this is why I make you fill it out over and over again, because now it should be ingrained in your head. Now just do that backwards. What quadrant will that land you in? 1, perfect. Draw a triangle in quadrant 1. And then what is your reference angle? Pi over 6. See how that's 6? It's just gonna match. It's either 3, 4, or 6, the only options. What goes across from pi over 6? 1/2, good. That means the other side, square root of 3 over 2. Perfect. Let me pause this. Is anything negative? No. Okay, perfect. We're in quadrant 1. That's the work I'm looking for. That is your work. Now we're going to answer the question. Secant means you're going to flip the x value. So it would be 2 over square root of 3. And then you rationalize that 2 square root of 3 over 3. So I guess another good thing to write on your test. Oh, well, I already have it up here. I was going to say this would be good to write on your test, but I already wrote it. It's just that R is 1. For the unit circle, R would just be 1 for all of these. All right, you guys can pick another one. We did one that's a 6th. Maybe pick one that's a 4th or a 3rd. So we're doing like something of each. 16. Oh, well, we can. That's the one that's in degrees. Let's do the one I gave you one problem that's in degrees. The rest are in radians. If you go 300 degrees, what quadrant are you in? 4. Perfect. Draw a triangle in quadrant 4. I feel like the reference angles are harder to come up with when it's in degrees because you have to actually like think about it. It's not just automatic. But if you went 300, what's your reference angle? Good. Perfect. 60. What goes across from 60? Square root of 3 over 2. That means the other side is 1/2. Which one gets the negative? Good. That's your work. That's all I'm asking for. So just do it. All right. Sine is the y value. So it's negative square root of 3 over 2. All right. Let's do one that is a 3rd. Let's do 25. Where is 2 pi over 3? 2. Good. And again, that's why I have you fill in the unit circle so many times, because after you do that enough, it'll just kind of come to you. You don't have to really think about it. Reference angle is pi over 3. Across from that is square root of 3 over 2. Down here is a 1/2. Which one gets the negative? The 1/2. Perfect. That's the work. Cosecant means you're going to flip the y value. So we're going to flip this one. It would be 2 over square root of 3, which is 2 square root of 3 over 3. You're probably like, hey, Miss Cole, isn't that the answer we got for this one over here? Yeah, that's why I'm so strict about the work, because there's so few answer possibilities that you could just guess them. So that's why I want you to draw the triangle or circle. All right, let's pick one that's a 4th, just so we're doing like one of each here. So 18. All right, where is 7 pi over 4? 4ths, good. 8/4 would be the whole way around. So 7/4 means you didn't quite make it. So your reference angle is pi over 4. And then that means both sides of the triangle square root of 2 over 2. Now, which one gets the negative, the x or the y? Perfect. That's your work. Cotangent is x over y. I'll write this out. If you want to, you can, but you technically don't have to. Because what is anything over itself? 1, it's going to be -1. Good. I'm leaving these for you so you have more to practice. And again, if you want even more, just go back to homework 4. It'll keep giving you problems. All these answers are on Schoology. I have a picture of the whole study guide on there. So my suggestion is do the ones we skipped and then check your answers.